Today we're going to tackle a problem that you might not even be able to solve in high school. If you're a top student and interested, come try it with me. Let's simplify this expression. 1 times 2 plus 2 times 3 and so on, all the way up to n times n plus 1. In the end, we need to write this expression as a formula in terms of n. Now you'll notice that if you keep calculating, the result will be infinitely large. This means we have to process its general form, n times n plus 1. After processing, similar to listing terms, it will turn into the form of the difference between two terms. Once all terms are in this form, some parts in the middle will cancel out, and only then can we get the result we want. So at this point, how should we think about n times n plus 1? Let's all think about this. N times n plus 1 is the product of two natural numbers. If I want to write it as the difference of two things, it should be some multiple of n times n plus 1 minus some other multiple of n times n plus 1. So to maintain consistency in form, we can first multiply it by n times n plus 1, then multiply it by n plus 2, and then by another number after that. After writing it in this form, we can understand it as n plus 2 times n plus 1. So what should we subtract? Let's write another number before it. N minus 1 times n plus 1. After writing it out like this, you'll notice that n plus 2 times n plus 1 minus n minus 1 times n plus 1 is just 3 times n plus 1, isn't it? So as long as I multiply by 1/3 at the front, this equation will hold true. After writing it out this way, we'll find that every term can be split according to this logic. So the original expression will equal 1/3 times. Note, when it's 1 times 2, that means n is 1. So this equation becomes 1 times 2 times 3 minus 0 times 1 times 2. Then when we add the second term where n is 2, it's 2 times 3 times 4 minus 1 times 2 times 3, and so on and so forth, all the way to the last term, which is n times n plus 1 times n plus 2 minus n minus 1 times n plus 1. As we write out this problem to this point, notice that 1 times 2 times 3 and the negative 1 times 2 times 3 cancel each other out. So at the very beginning, we're left with a 0 times 1 times 2, which is a negative term, and in the end, there's only one positive term left. Therefore, the final result is just 1/3 of n times n plus 1 times n plus 2, and with that, we finish this problem. Problems like this, even at the high school level, are only encountered in the section on mathematical induction. Did everyone get it?